Research Methods, Lecture 4. Populations and Samples. First of all, you should know what is the target population. Target population means a complete set of people, data, subjects, or anything that have the criteria that you want to measure. For example, if you want to investigate about smokers, your target population will be all the smokers in Iraq. However, practically, it's difficult and sometimes impossible to get access to all the target population, especially if the size of this population is very large. So you need to go to the accessible population, which is some portion of the target population, but has a chance to be selected and from which your sample can be chosen. For the same example, the accessible population will be all the smokers in Baghdad. So you can see that this sample or this accessible population will be easily accessed when compared to the target population. The sample is a smaller part of the population that serves as a reference group for the estimating and drawing conclusion about the population. So in this case, your sample will be 1,000 of smokers. So you select your sample from the accessible population in order to get reference to the target population.
When you do your study, you will have a sample and do statistics in order to get results that can be reflected to the population. It's difficult to get the true value of the population, but you have a statistical estimates that can be reflected to the population. So all the statistics are just estimate of the true value. Therefore, the sample should be representative as possible to the target population and should be large enough to get accurate results. It's important to take care of your sample so that your results can be generalized to your population values. If we have this target population in which males represent 25% and females represent 75%. If for any reason we take a sample from this target population in which we equalize the gender so that males represent 50% and females 50%. In this case, the characteristics of males will be overestimated and that of females will be underestimated when we compare it to the target population. Therefore, our result from such a sample will not represent and cannot be generalized to the target population. And this is called a biased sample. Consider you have this target population of people with the following ages, starting from 18 and end by 25. The average age is 21.5. What are the possibilities of taking samples from this target population? If you get sample of 2, these population that you will get. These are the age, and this is the true age of the target population. Sometimes you are far from the target population age, sometimes you are accurate. In general, if the sample consists of 2, you will get this variation from the true value, either below or greater by 2.5 from the true value. If we increase the sample size and get a sample of 3, in this case, the mean age will be much closer to the real value, and the variation will be either below or greater by 1.17. So you can see that as we increase the sample size, the variation is decreased. That means you are closer to the real mean value by increasing the sample size. Look again at the age of this target population. If we take the same example but increasing the age range from 18 to 25, now it's 18 to 40. In this case, the mean age is 29. The same possibilities if we take a sample of 2. The variation will be either below or greater than the true value by 7. So the variation is greater. Why this happened? Because the variation in the target population is increased. And again, if we increase the sample size to 3, the variation will be less and you are more closer to the real value. But the variation is greater than that of the first example. We can learn from these two examples that as you increase the sample size, you will be much closer to the real value. And if your parameter that you want to measure is of great divergence, that means you need to increase your sample size much more in order to get accurate results. Different types of sample. The first one is random sample or probability samples. In this type, everyone has equal chance to be selected. The aim of this type of sample is to make the sample as close as possible to the target population by decreasing the chance of error and limiting the sampling bias. The second type is non-random or non-probability samples. This is usually easier and more convenient, but the probability of selection is not known. Therefore, the chance of error and sampling bias is greater. The result of this type of sample is just limited to the sample and cannot be reflected to the population. Random sample can be categorized into different types. First of all, simple random sample. This usually can be achieved using a computer random number generator or a computer software in which we give the criteria that we want, like the sample size and the type of groups or the number of groups, so that the computer can give us a table with a random number. Each number represents the type of groups. The second one is cluster or multi-stage random sample, which is similar to the simple random sample but consists of 2 or more stages. For example, if we want to take a sample of dental students from Baghdad, we can first do randomization for the dental colleges, and then from these selected colleges we can do randomization for the students from different classes. So in this case we have 2 stages of randomization. The third one is stratified random sample. In this type, we need to classify the sample or patients according to different characteristics, like age, gender, ethnicity, type of malocclusion, and from each subcategory, we can do randomization. Therefore, this type of random sample considered as the strongest type of random sample. The fourth type is systematic random sample. In this type, we have to do some criteria for selection. For example, if we have a list of patients and we need to select from this list, we can select the first 5 of each 10. Or we can select number 1, 11, 21, 31, 41, and so on. This type is the weakest type of random sampling when compared to the others. and the stratified is the strongest type of random sampling. For the non-random sample, we have two types. The first one is a convenience sampling, which is the simplest type of sampling, and it just depends on the availability. For example, if we want to do a survey for dentists, including 30 dentists, we can select the first 30 dentists that we meet. On the other hand, the quota sample is just similar to the convenience sample but has some predetermined criteria. For the same survey, we can use dentists from different branches. So the 30 dentists can be 5 from each branch so that it will be more generalizable to the target population of dentists. But in general, both these types are weaker than these 4 types. The random sample, in general, cannot guarantee that the sample will not be different from the target population, but at least it eliminates the possible reason that it makes it different from the target population. That's why it's stronger than the non-random sample. This is an example of simple random sampling in which we randomly select patients from the target population or accessible population. This is usually not done by us, but by special softwares. For the stratified random sampling, you can see that first of all, we need to categorize a patient according to different classification or different categories or different strata. From each class, we will do randomization or simple randomization. For the systematic random sampling, we can select like this, number 2, 5, 8, 11, so we skip 3 after each one. So there is some system for selection. However, this can be considered as a weakest type because it may result in unbalanced group. For example, patients just females or just males, which does not represent the target population. Sample size and statistical power. As you saw from the previous example, that sample size is of great importance to get a reliable result. Therefore, if the sample of adequate size, our result will be more relevant to the clinical practice. It's important that the sample size should be calculated before initiation of the study in the planning stage. This is preferred and it's called a priori calculation. So if we calculate our sample size before starting the study in the planning stage, this is called a priori calculation, which is a preferred or advised type. But if we calculate the sample size later on after completing the study, this is called post hoc calculation and is not generally advised because it will not be of great value to our study. The probability of making type 1 error is called alpha, which is the probability of finding false positive results. That means in reality there is negative result, but we found positive result, which is wrong. This is usually set statistically as 5%. So we have only 5% to make a false positive result, or type 1 error. while the probability of making type 2 error is called beta, which is the probability of making false negative result. That means in reality there is a positive result, but we couldn't find it. Therefore, the power of the study, or the ability to find this positive result, is 1 minus beta. Beta level is usually set statistically as 20%, therefore the power is 80%. If you want to calculate the sample size, you need to know the followings. First of all, the level of significance, or alpha level, which is 5%. Second, the power of the study, which is usually 80%. Third, the effect, or the smallest difference between the two groups that you want to investigate, which is considered clinically significant. And you should note that as the effect is getting larger, that means it's easily to be found. Therefore, the sample will become smaller. But if the effect is very small, it's difficult to be found, therefore the sample size will be greater. And finally, standard deviation. This is usually got from other studies or from a pilot study that you can do. As the standard deviation increased, this means the variation of the sample is increased, and in this case the sample size needs to be increased too. But if the standard deviation is small, this means the sample size will become smaller. When you calculate the sample size, you also need to account for dropouts, or the number of subjects that will be lost during the study. Therefore, there will be an additional of 10 to 50% of subjects to account for these dropouts. Sample size calculation is very important because by testing few subjects, that means you may not find a significant difference which is in reality available. So the type 2 error will be greater. But on the other hand, taking too much patients may be a waste of time, effort, resources, and unethical at the same time, because you are subjecting patients to potentially ineffective treatment maybe. Therefore, you should calculate the sample size from the beginning to know the exact number of subjects that you need to test. In case of qualitative studies, when you don't have numbers, just information or description, you don't have to calculate a sample size, but on the other hand, you need to reach the level which is called a saturation point. In this saturation point, there will be no additional information that you can get from the extra number of patients. Therefore, when you just get a repeating information from the additional patients, you can stop here and do your analysis. If after calculation the sample size, you find that it becomes very large, that cannot be practically obtained, what you can do in this case? There are several options to solve this issue. However, most of these are just compromising your study or make it weaker. The first option is to increase the level of significance or to increase type 1 error. The second is to decrease the power of study or decreasing type 2 error. Third is to increase the effect size, as I told you before, making the difference between the two compared group greater. This will be easier to be found so that the sample size will become smaller. Or you can modify your study design, for example, changing it from clinical trial to cohort study, So this decreases the level of evidence, but you can get a sample that can be easily obtained. And if these four don't work, you can give up the study and search for another idea. Data collection. Data collection and management is a very important step in your study, and it should be carefully managed and planned from the protocol stage. And it's also important to pilot your data collection procedure before you start your study, because poor management of data collection can jeopardize the whole project. Types of variables. The researcher usually tests the relationship between two types of variables. The first one, called independent variable, or the variable that can be manipulated by the researcher. It's considered as a cause or can explain the changes in the other type, which is the dependent variable. This is a response variable that can be changed by the manipulation of the independent variable. So the independent variable considered as a cause, while the dependent variable considered as the effect or the result. We can make the manipulation in the independent variable and measure the changes in the dependent variable. We also need to know the effect of what is called confounding variables, which include any factor that is not related directly to the study but can affect the outcome, or the dependent variable. For example, if we want to test the effect of smoking on lung cancer, this is the independent variable and this is the dependent variable. If our sample is not taken carefully, the age can be another factor that affects the lung cancer in addition to smoking. So this is a confounding variable that can contribute with the independent variable on the outcome. So the confounding variables need to be controlled from the beginning, and the best way is to control confounding variables by random sample, so that their effect will be distributed evenly between groups. Another example is to test the effect of alcohol on coronary heart disease. In this case, smoking can be considered as a confounding variable that can be contributed with the alcohol in making coronary heart disease. So these are the confounding variables that need to be controlled from the beginning. Validity and reliability. The study is called internally valid if the relationship between dependent and independent variable is free from the effect of confounding variables. This is usually achieved by adequate randomization. External validity means generalizability, or the results can be reflected to the population. This can be achieved by getting a representative sample to the population and by adequate randomization method. So you can notice the importance of randomization on controlling confounding variables and on the validity of the study both internally and externally. Reliability represents the measure to which the results are repeatable or reproducible. On the other hand, the study is stable. In your study, you will test some measurements by yourself on two different occasions, and you should get no significant difference between the two measurements. This is called intra-rater reliability or intra-examiner reliability. And you should also do inter-rater reliability or inter-examiner reliability when you do a measurement and compare it with another one measurement, and you should also get no significant difference between the two tests. This can be usually done using an intra-class correlation coefficient test. Types of data. Generally, data can be classified into numerical or quantitative data and categorical or qualitative data. For the numerical, it can be divided into discrete, which include values that are clearly separated without any fractions, or continuous, that include any number in between, even with fractions. Interval numerical data means that the data are separated by equally spaced interval, like the difference between 1 and 2 or the difference between 4 and 5. Ratio data means that there is an equal ratio between the data, like the ratio between 8 and 4 and the ratio between 4 and 2. Categorical data can be either nominal, in which there is no ranking between the groups, like male and female, or yes and no, or the difference between colors, so both or all have the same rank. Or it could be ordinal, that means there is a ranking between the data, like mild, moderate, severe. So one is greater than the other.